You have the battery SoC, the fuel cell. Can you take us a little bit into what it actually takes to charge a vehicle, and also what you do when you do that with hydrogen?
Yes, on the first glance, it seems kind of straightforward. So you connect either AC power, and then the vehicle converts it to the DC and charge the battery, or in most cases, I guess today, you connect the DC power to your most likely CCS socket. So that's the standard every electric vehicle use right now. And then you supply the DC power directly to the vehicle. There are two, let's say, layers or two kind of components involved. There's some kind of communication unit or some kind of communication interface, which tells the vehicle how much power, how much current, what voltage can the charger provide. And then the vehicle tells the charging station how much power, what current, what voltage does the vehicle require. So that's the communication side of the things. And then there is some power electronics which converts the either AC or DC to the power the vehicle requires. So it's an AC-DC converter converting the AC power from the grid, or DC-DC converter converting any kind of DC power to the DC current vehicle requires. So those are the main, let's say, components of the charging station. Of course, there are others, but I think that's a little bit on the technical detail.
Yes. And when you want to do this now with hydrogen, I guess something comes on to that.
Yeah, so if we want to charge the vehicle with the hydrogen, we always add a fuel cell. There is a way to control the fuel cell, which utilizes the DC-DC converter. So we add some DC-DC converter for the fuel cell, and there is usually a battery involved. By battery, it's because the fuel cell cannot react quickly enough for the change in the vehicle requirements. It's most important is it is in case the vehicle suddenly stops the charging session, disconnects the charger itself, then and we are running the fuel cell on full power. We need to dissipate the energy somehow. So we have the battery to take care of that. Also, the battery provides power for the peaks, and it's also possible to use the battery to increase the immediate charging power. So, for example, in our applications, we are usually starting with a full battery. So we start charging with a higher power, and then if the battery is depleted, we only have the fuel cell power, and we decrease the power for the vehicle. So it can be also used like this.
Yes, I know.
Then there is.
Yes, sorry, please go ahead.
Also, a little bit, little extra job for the main control unit, because all the components have to be managed somehow. We call it usually the power management. I don't know if it's like official term or if we just make it up, but we call it power management, and that takes care of the battery SoC, vehicle SoC, all the DC-DC conversions, fuel cell, hydrogen storage, and everything.
Yeah, so okay, you counting on those devices which you mentioned. So you have the battery SoC, the fuel cell, the vehicle that you're charging. You've had the hydrogen tanks that you fill. So there's really a lot of controls going into the. I know that. I mean, you work at Devin, and I know that you guys have been quite innovative in this.